Do you want to finish a room in your basement? Well, this video will show you how from start to finish. Stick around to the end for the final reveal. I'm Travis and this is how I do things. Let's get into it. The first thing I need to do is take a look at my space, which is located through this door at the end of my hallway. Well, here it is. What do you think? It may not look like much yet, but it will. Now, before I start any of my work, I need to make sure my basement is a good place to finish. You're going to want to do a radon test, and I put a link to a DIY home kit down below. Radon is a radioactive gas found in some basements, and you're going to want to make sure you have safe levels in your basement if you're going to be spending any time down here because it's known to cause lung cancer. If your levels are too high, you'll want to have a radon reduction system installed like this one. My builder installs them standard in all their homes. When the system is installed, the basement floor is sealed, so no radon can leak through, including the sump pit. Then a hole is drilled in the concrete and this pipe is installed. This pipe goes up to the attic where there's a pump. That pump creates a vacuum, which pulls the radon up from the drain tile and safely out of your home. Next, check your walls and floors for any cracks bigger than 1/8 of an inch. If you see any, fill them in with polyurethane caulking. I'll be caulking the expansion joints as well as the joint between the slab and the wall. This will help prevent radon, insects, and water from coming into your basement. I tried to use a self-leveling caulking around the perimeter and it was just too thin and the crack just kept soaking it up. For larger cracks like this one, I would go with something thicker like this product. After 2 coats of this, I was good to go. I put a link to both of these products down below. Speaking of water, you also need to check for any signs of moisture on your floors or walls. Even if you don't see any signs of moisture, be sure to check the humidity of your basement, and then if you need to, get a large dehumidifier. Ideally, your relative humidity should be between 30 and 40%, but you should be good with anything below 50%. Then test the floors and walls by taping a piece of clear plastic to them. If you don't see any condensation on the plastic after a day, you should be good. Once you're happy with the condition of your space, you'll need to take measurements of the space and look for anything that might make it hard to frame off the room. I also want to look around for anything I might need access to later. You'll need access to any HVAC dampers and water or gas valves. I also try my best not to cover up any plumbing if possible. A lot of people like to make their basements look just like the upstairs part of their home. Well, I take a slightly different approach in that function is more important to me than form, which is why I'll be doing a painted ceiling with no drywall, like I've done here in the rest of my basement. In some cases, you can move HVAC or plumbing into different parts of the basement that will stay unfinished. Seeing as how I'm going with an exposed painted ceiling, any ductwork, electrical, or plumbing will just get painted black. I have a lot of things along this outside wall, so I'm going to leave a narrow walkway right here so I can access all of it later. On the other side of this wall is a bathroom. So this wall has a lot of plumbing and some electrical junction boxes in it. So what I'm going to do is build a closet right here that will sort of cover some of that stuff up, but also give me access to it later. This room will be an office, not a bedroom, so I'm not required to have an egress window. If you're building a basement bedroom, you must have a method of exiting the basement in case of a fire. Be sure to check the building codes in your area. I have an egress window in this part of my basement, so I can get out quickly if I need to. If you need an egress window, be sure you can fit the right size window to meet building code. Having an egress window added is messy, and I recommend having that done early in the building process. When you have a pole like this in the middle of your room, it's best to try to frame around it to hide the pole. Plus, I have a situation where the door opens this way. I'm going to need a place to put the light switch, so this wall will be the perfect place. So I figured out that my wall is going to end right about here, but I still have a lot of ductwork here to deal with. So what I think I'm going to do is create a soffit to cover all this stuff up with 3 recessed lights that will help light a desk and maybe a future workbench. I also like to add crown molding to the unfinished painted ceiling because it covers the edge of the drywall and makes it feel more intentional. Now we have the dimensions of our space. We know that we don't have any water issues and we know what obstacles we need to work around. So now we can start designing our room. There are lots of free tools you can use to do this on your computer. I like to use floorplanner.com. It allows you to design the space, add furniture, and then even do a virtual walkthrough in 3D. When you plan your outside wall, be sure to account for the extra thickness of closed cell foam board insulation. I like using this foam board because it's easy to install, mold resistant, and it's considered a vapor barrier. Try to think about where you might want to put lights, light switches, and outlets. In addition to that, also take a look at your circuit breaker box and make sure there's enough room in case you need to add more breakers. Assess your ductwork and figure out how you might get a vent or two in your room to get AC and heat. Now, my office isn't going to require any plumbing, but if your room is, make sure you know where you can tap into any existing water feed lines and drains. Once you plan everything out, be sure to get all the proper permits before starting your work. Take this process one step at a time and you shouldn't get overwhelmed. I also like to put things into a calendar so I can start to figure out when things need to get done and then make sure they're done on time. I put a list of some of the things you might need to do in the list down below. I also like to make a Google Keep list so I can check things off as they're completed. And if you don't want to do all the work yourself and you plan to hire subcontractors, be sure to get at least 3 quotes for each thing you need to have done. And then don't hire a contractor just because they're the cheapest. What you're looking for is the best cheap contractor.
The room is planned, permits are pulled, and I'm ready to start working. The first thing I need to do is install some fire blocking and insulation.
So what the heck is fire blocking? In the event of a fire, holes and gaps in the wall and ceiling cavities provide ventilation of the fire and allow it to spread faster. Here's a diagram I made to show the situation I'm trying to improve. Here you can see the sill plate, ceiling joists, insulation, and the foundation wall. You can also see a nice little fire that started at an outlet inside of the 2x4 wall. The drywall contains the fire within the wall, but any air being allowed in will feed this small fire and make it a large fire pretty quickly. At the top you can see the fire blocking, sealing up the cavity and slowing the burn, as well as containing poisonous gases from melting plastic and foam. And now that you know why fire blocking is so important, let's install it. Spray foam is great, but if your builder used it, you may need to whittle some of it away so your material goes all the way back to the sill plate. If you don't see any insulation here, then either have expanding foam insulation installed or install 2-inch foam board using foam board adhesive and then caulk around the edges. It's much easier to do this before you install your fire blocking. Now measure from the sill plate to where the top plate will end so you know how wide to cut your material. I'm going to cheat a little bit by using some of my previous work as an example. Mine needs to be 8 inches. Over here you might have noticed that I use 3/4 inch OSB for my fire blocking. Well, I don't have any more of that, but I do have this 1/2 inch piece of drywall and it'll be super easy to cut, so I'm going to go ahead and use that. All I need to do to cut the drywall is mark my cut and use a straight edge to score the paper with a knife. Then break it and cut the paper on the other side. To install, I'll put it all the way against the sill plate and then screw it to the ceiling joist with drywall screws. In my area, you can use either 3/4 inch wood structural panel or 1/2 inch drywall, and it needs to be nailed or screwed to solid wood. Any gaps need to be backed with the same material. Then I'll use fire-resistant expanding foam to ensure the fire blocking is sealed at the sill plate. In addition to adding all of this fire blocking, when I get to my framing and electrical, I'm also going to be filling all the holes in my top plate with the same fire-resistant foam. Adding all this fire blocking is actually a nice safety feature, but in my local area, it's required by the building code. I'm leaving my ceiling exposed to be able to access things later. While drywall or drop ceiling would have improved my fire blocking, most of the electrical is in the walls, and I have at least improved that. Now that all of our fire blocking is in place, let's work on some insulation. This is an interior wall, so it's perfectly fine. But in the past, people have used fiberglass batt insulation on their foundation walls covered with a clear plastic vapor barrier. Don't do this. This allows moisture to get wicked up into the fiberglass insulation and then is actually held there by the clear plastic vapor barrier. More than likely, you're going to have a mold issue in that situation. When my house was being built, my builder actually used foam board insulation on the outside of the foundation walls. This is actually the best way to insulate your basement because it keeps your wall warm but also allows it to breathe. But I want just a little bit more insulation in my basement, so I'm going to be adding some more on the inside. You should only do this if you have a very dry basement. I'll be using this rigid foam board insulation, mostly because it's super easy to install yourself. But you could also use spray foam, which you might need to hire a pro for that. Whatever insulation you choose for your basement, I recommend using closed cell foam for its moisture resistance and vapor barrier. To install this foam board insulation, take a measurement from the floor to the fire blocking and then cut the foam board 1/4 inch shorter than that length with a straight edge and then just snap it off. Do a test fit to make sure you cut it right, then apply foam board adhesive to the back of the board. Now put it in place and apply pressure all over the surface. You may need to put something heavy against it to hold it in place until the glue dries. Repeat these steps to cover the rest of your wall. You should only be using this foam board in areas that will be covered by drywall. Then use polypropylene sheathing tape to seal the gaps between each board. I'm using this Tyvek tape. Finally, seal any remaining gaps with either caulk or spray foam depending on the size of the gap. Personally, I caulk the bottom edge of the foam board, but I've seen varying opinions on this. If you have more information, please leave a comment below. I want to point out one more time that most building codes require you to cover this rigid foam board with drywall, so don't put it anywhere you don't intend to have drywall. Now that my room is nice and warm, I'm going to start looking at the ceilings to see if there's anything that needs to move. I have a hose spigot valve right here that needs to move so I can access it after I install my soffit. I've decided I'm going to work on this valve first. I need to take a look at my plumbing to see where would be the best place to put the new valve. Once you figure out where to put the valve, determine all the pieces you will need to install the valve. Now take your list and head to your local Home Depot or hardware store and pick up all the fittings. It's best to try to get all your supplies before you shut the water off in your house. That way you won't inconvenience your family any longer than you need to. And now that I have all of my supplies, we can get started. First, I need to turn off the water and drain the water to any plumbing I plan to cut. When working with copper pipe, it's very important to get as much water out of the line as possible. If water is still in the lines, you won't be able to solder up the new joints. As you can see, there's very little water coming out. That's because I need to open up the hose spigot to vent the line. That certainly did the trick. Now we're ready to cut the existing pipe. Before you do that, take a good look at it and try and find the right place to cut it. Try and find a place that has a straight that's long enough that you can cut it easily and install the new fitting. I also try to look for a good spot to make my cut that doesn't have a lot of things around it that are flammable that might catch fire when I'm trying to solder on the new fitting. Using one of these copper pipe cutters is super easy. This is a compact one meant for small places. You just put the cutter on the pipe and tighten the knob until you feel pressure. Then turn the cutter 2 to 3 times. Then turn the knob a quarter turn, then turn the cutter again. Repeat until the pipe is cut. You may have some residual water still in the lines at this point, so be ready to catch it. I recommend cutting all your pieces and test fitting your assembly. Once it looks good, clean all the pipe ends with emery paper and the fittings with a wire brush. You can also use a special combination tool for this. I put a link to one down below. Then apply flux everywhere there will be solder and then reassemble. I like to test fit it again to get everything in the right orientation. Now solder all the connections in the assembly. Take your time. The heat of the pipe should be melting the solder, not the flame. It's much easier and safer to solder as much as possible on this assembly before you attach it to the existing plumbing. The solder will want to flow where there is heat and flux, so focus your heat on the fittings. If you're concerned about burning yourself, wear gloves. If you're uncomfortable with anything I cover in this video, there is no shame in hiring a professional plumber. Now I just need to let my pipe cool down completely. I only briefly covered how to solder copper pipe in this video because I have an entire video that covers it in great detail, and you can watch that video by clicking the link above. As I said before, it's a good idea to protect anything that might melt or burn with something non-flammable before you start soldering. Once the assembly has cooled, I can connect it to the existing plumbing using flux and solder and then install some supports. If the hangers are plastic, just be careful not to melt them. The original plumbing used what's called a shark bite fitting. And ordinarily I don't like using these because I think they're prone to failure. However, in this case, the ceiling will be completely exposed, so I will see this fitting forever. That being said, if it does leak, I will see the leak immediately. So in that case, there's not much risk, so I'm going to reuse this fitting. To remove a shark bite fitting, use an adjustable wrench or a shark bite tool to apply pressure on the end like this. Then just pull the pipes apart. To install, just push the pipes into the fitting. Then I finish off this by just installing any additional hangers I think I might need to support the valve. I'm all done moving that valve, so now I'm going to turn my attention to some of this PEX piping. This PEX piping is right in the way of where my framing is going to be for my soffit that's going to cover up this beam. So I'm going to move this pipe right here a couple of inches out.
This PEX pipe is really easy to work with because it's so flexible. All I need to do is pry off the old hangers, move the pipes where I want them, and install new hangers. Easy peasy. If you do need to cut any PEX plumbing, you can do that easily with a set of these cutters. I put a link to one down below. If you need to make any new connections, you can do that with one of these crimping tools. This is a good tool for DIYers, but be aware that the brass fittings you use with this tool cause minor restrictions in the flow of your system. Professional plumbers use a special tool to flare out the end of the pipe so there is no restriction. Now slowly turn on the water and inspect all of your work for leaks. If you have a leak, you'll need to turn off the water and drain the pipes again to repair the leak. The plumbing is moved and I'm ready for the next step, which is adding any heating or air conditioning to make my room nice and comfortable. To get the best and most efficient heating and cooling in your basement, it's a good idea to add a second zone. Adding a new zone means adding new return and supply ductwork specifically for your basement. Then motorized dampers, a controller, and another thermostat are added to control the flow of air to the different levels of your home. I wasn't confident adding a second zone on my own, so I actually relied on a professional to do that. But now that I have my second zone, it's very easy to add a supply to this new room. There should be a damper on every supply, so you can tune the HVAC system to get even heat or AC to all your rooms. To install my new supply duct, I'm going to have to tap into this existing round ductwork right here. But before I can do that, I need to move the damper that's at the end of this to a point somewhere after my new T. You need to be able to access your dampers after the room is finished. But my ceiling is going to be exposed and painted black, so honestly the best place to put it would be right here in the middle of my room. I see a joint further down the line in this tube right here that looks like it'd be an ideal place to put my damper, so let's move that first. To move the damper, I just need to unscrew the duct at the joint, unscrew the wing nut, and remove the damper. The hole can be covered up with aluminum tape. Then to put the damper in the new location, I remove the aluminum tape, unscrew the joint, and pull it apart. Then I just drill a hole and install the damper. Now I can screw the joint back together and retape it with aluminum tape. Sealing all your joints just helps improve the overall efficiency of your HVAC system. Now that I got my damper moved, I can install my new supply duct, but first I need to see where it will fit. Seeing as how this is a basement, so it will only see heat and heat rises, it would be ideal to mount this duct low on this new wall. But the rest of my basement has them all in the ceiling and I have no issues with the heating, so I'm going to stick with that theme. It's also the easiest solution. Take a look at your setup and do what's best for you. As I suspected, the duct that I want to use doesn't quite fit in between my joists, but they didn't have one smaller than this, so what I'm going to do is try and modify this to see if I can get it to fit. I can modify the duct with sheet metal cutters while referencing the area the duct will go. Then I secure it with aluminum tape until it can be screwed in place. Fits like a glove. This is called a saddle tee. It's called that because it fits over the existing pipe and makes the install a little bit easier. Once I figured out where the duct will be, I put the saddle tee in the pipe where it will go and then mark out where I need to cut the hole. Seeing as how the hole needs to be cut on the top of the duct, I could either take out the screws and rotate the duct or just pull the whole duct down. In this case, it was easier to take the duct down and make the hole in the floor. To make a hole like this, I use a heavy-duty razor knife and a hammer. I give all the credit for this idea to Home Renovision. He has a lot of great tips like this. The hole doesn't need to be perfect. I make the hole a little bit smaller so I can cut small tabs that can bend in towards the T. Now that I have the hole made, I can screw the saddle to the tube. On a side note, this tube is very sharp and I highly recommend wearing gloves. I know I needed a 90 coming off this T, so I decided to do that now while it's easy to access. These adjustable fittings are really cool. They adjust anywhere between 0 and 90 degrees. To get a 90, you just need to line up all the short sections of the fitting. Then I screw the 90 to the T and tape up all the seams. By the way, I'm using number 8 self-tapping sheet metal screws for pretty much everything. Then I reinstall the round duct. Next, I take a measurement to see how long my new duct needs to be to put the supply where I want it. In this case, I got lucky and I can use the full length of tube, but if you do need to cut your tube, it's much easier to do it when it's flat before you form it into a round duct. Once you're ready to form it into a round duct, all you need to do is connect the seams and snap it together. When you run into a situation where you have two pipes that are the same diameter and one needs to go into the other one, you have two options. You could get a little coupler like this that has crimped ends on both sides. Or you can use a set of these crimping tools to make an end on the end of your pipe that looks just like this. I'll put a link to something like this down below. Before I install the supply hood on this duct, I'm going to install another damper so I can control it later once it's all installed. To do that, I just drill a hole in the tube, install the damper, and then thread on the wing nut. I'm going to start by leaving these ducts wide open. Open is when the handle is parallel to the tube, and closed is when the handle is perpendicular to the tube. Then I can install the duct with sheet metal screws and aluminum tape. Be sure to install the ductwork in a position that makes sense for the type of ceiling you're going to have. Once the duct is installed, I can finish up by making sure all of my seams are taped, and then I have any hangers installed that are needed to support the ductwork. The heat is flowing, so now I'm going to need to do some framing. I'm going to need to frame some walls, a door opening, and a soffit. To start framing a room in my basement, I like to get out my laser and a Sharpie and mark where the bottom and top plates will land. The laser is nice because you can do all of that at the same time. I put a link to this laser down below, but if you don't have one or don't want to buy one, you could also lay out your walls using a very straight long board and a square. I just mark out the inside edge of the wall. If it helps you remember, you can put an X on the side the wall will go. I like to use a square in the corners just to make sure my walls are running perpendicular. I also like to mark out any openings for doors. During the process, pay attention to anything above your future walls. If you're concerned about clearance to anything and you don't have a laser, check with a plumb bob and make adjustments as necessary. Once I can see all of my walls, I measure the total length of the wall so I can figure out how many studs to order. If you're using 16-inch stud spacing, take the total wall length and multiply by 0.75. Then add a few studs for each intersection for drywall backing. Also add a few more studs for each door or window opening. Then take your final number and multiply by 1.15 to give you 15% extra for waste, bad material, or mistakes. Don't forget, you can return any unused materials. You also need longer studs for top plates and pressure-treated bottom plates. The top plate is the board that attaches to the ceiling joist, and the bottom plate or sole plate attaches to the floor. Since the bottom plates are in direct contact with concrete here in the basement, the pressure treating helps prevent them from rotting. The studs are the vertical pieces that connect the bottom and top plates. I like to use the longest bottom and top plates I can to keep the wall continuous. The length will more than likely be limited by what you can get down into your basement or fit in your car or truck. Check your local building code to ensure you're using the correct fasteners. In my area, we need to use 16D nails, and they should be galvanized if you're nailing into pressure-treated wood, which down in the basement we will be. I start by measuring my markings and cut my bottom and top plate. I have to frame around a support beam and some plumbing, so I'll have several top plates for one bottom plate. Then lay the top and bottom plate next to each other and mark out the stud locations. Put a mark at the end for the first stud, and then the next stud will start at 15 1/4 inches from the end. I put an X on the side of the line the stud will go. Now move your tape measure to the line you made, and then just make a mark every 16 inches with an X ahead of the line. Keep marking out a stud every 16 inches until you get to the end. When you get to the end, mark out another stud right at the end. Now make sure you mark out a stud to attach any joining walls as well as backer boards to support drywall. I like to mark out a sideways stud for these situations. Marking both the top plate and the bottom plate at the same time not only makes it faster, it ensures you won't make any mistakes. If you're making a longer wall that requires more than one bottom plate, push the bottom and top plates together and continue marking out your studs every 16 inches. Remember, the goal is to be able to install 4-foot wide drywall panels and have the edges fall in the center of each stud. When framing around obstacles, I need to have studs every 16 inches for drywall, but also studs on the ends of the top plates to support them properly. Then I stack my top and bottom plate on top of each other to account for their thickness. And then I measure from the joist, or in this case, the fire blocking, down to the plates. You'll want to do this in a few spots so you can find the shortest distance. Then take that number and subtract 1/8 of an inch to ensure there's enough clearance to install the wall once it's assembled. If your joists are running parallel to the wall you're about to build, you may need to put some pieces of wood in between the joists so you have something to nail your wall to. In this case, I don't need to do that because I have a joist right above the wall. Now grab your studs and cut them to length. You can do this with a circular saw, but my preference is a miter saw out in my garage. The rest of my basement is finished, and I like to keep the dust down as much as possible. Once you have all your studs cut, lay out the wall on the floor so you can nail them together. This process is much more efficient than trying to nail the studs with the bottom and top plate already installed. However, if you don't have enough room to build your wall on the floor, you will have to build your walls by installing the top and bottom plate and toe nailing the studs to them. To build your wall, just align the studs with your marks and drive 2 nails into each stud. Be sure to wear safety glasses and hearing protection. Keep your hands clear of the area you're nailing. Sometimes nails will shoot out of the side of the studs. I like to do all the studs on one plate and then move to the other plate. Nail all the studs on just like you did before, except pay special attention to make sure the studs are perpendicular to the plate. If you have a stud with a little twist, you can nail one side and then pry on the other side until it lines up with your line. Then put in the second nail. Once your wall is built, you can lift the top edge of the wall into place. Hopefully your 1/8 inch left enough room for you to easily put your wall in place. If not, you may need to tap it in place with a hammer. Just be aware that this will slightly move the floor above temporarily, so don't do this if you have a rigid floor above, like tile, or you may damage the floor. I made a little bit of a mistake and I didn't account for this ductwork over here, so I wasn't able to lift my wall into place. Not too big of a deal though. All I need to do is take this big complicated wall and cut it right here into 2 walls so it's easier to maneuver. Once the wall is standing up, use your marks on the floor to get the wall into position. In the past, I've used a ramp set to secure the baseboards to the concrete floor. However, that sort of causes the concrete to kind of crack around it, so I've started using a hammer drill and Tapcon screws. I use 2 3/4 inch Tapcon screws in between every other stud. The other nice thing about these is you can easily remove them if you need to move the wall for some reason. To use them, you just drill through the bottom plate and into the concrete using the included bit. Then just install the screw. If you're breaking screws off, you may need to clean the hole out or drill a little bit deeper. Once the bottom plate is secured, I use a long level to make sure my wall is plumb, and then I nail the top plate to the joists. When I tried to install the second section wall, I ended up running into more problems. I was having issues getting around the dryer vent duct, so I had to remove that to get the wall into place. I'm actually kind of glad I had to remove it because it was way more clogged than I thought it would be, so this gave me a chance to clean it out. Now that this section of wall is in place, I made sure it lined up with the other section of wall, and then I used the Tapcon screws to secure the bottom plate and the 16D nails to secure the top plate. And I'll be framing for a sliding closet door, but the process is pretty much the same for any type of door you may want to use. Get started by measuring your wall and call your door supplier and decide what size door you want to install. Be sure to consider room for trim as well as any outlets or light switches. I do have kind of an odd situation over here where I have a bunch of ductwork right here. I'm going to eventually have a soffit. The top of the door is going to be kind of close to that soffit, so I have just enough room for the trim, so I need to make very sure that I keep the soffit as tight to that ductwork as possible so the door will fit. I'm not quite sure what that's going to look like yet, but we'll figure that out as we go. Once you figure out what size door you want to use, your supplier should be able to tell you the size of the rough opening. If you already have a pre-hung door, you can also measure the door frame and then add 1/2 inch on all sides. The 1/2 inch gives you room to add shims to ensure the door is plumb. For the top, be sure to add the 1/2 inch plus the thickness of any floor you plan to use. The wall you're going to be building for your door will include a top and bottom plate, just like any other wall. But when adding a door, you'll also need king studs, which are the same length as the rest of the studs in your wall, and they go here. Then you will need jack studs. These studs support the door header and frame the vertical door opening. The header spans across the top of the jack studs. For interior non-load bearing walls, you can just use a single 2x4 as long as the opening is less than 8 feet wide. If you do need a load bearing header, you'll need to read your local building codes to make sure you have a proper header. Finally, cripple studs go in between the header and the top plate. For a load-bearing wall, they help to support the top plate, but in a non-load-bearing wall, they're pretty much just drywall attachment points. And now that we know what we're doing, we can start building our wall. I like to start by taking a Sharpie and marking out the wall, including the rough door opening. Next, I cut my top and bottom plate to length, and then mark out the door opening on the bottom and top plate. Then I mark a stud on either side of the door opening for the jack studs, and mark that stud with an O. Then right next to that, I mark out a king stud on both sides with an X. Lastly, I mark out the rest of the studs 16 inches on center on the top and bottom plate. You don't need to mark out studs on the bottom plate where the door opening will be, but you should mark them out on the top plate. Nothing has been easy for me in this room. As you can see, there's all sorts of ductwork and plumbing and a beam. Nothing has been easy. So this is going to continue to not be easy. As you can see above me, there's a bunch of plumbing. I'm going to need to space the wall down just a little bit so I have room for all that plumbing, kind of like I did right back here on this wall. Then I measure, cut, and install my studs and king studs. Now I take my rough door opening height and subtract 1 1/2 inches to get my jack stud length, and then I cut 1 for each side. The jack studs will be nailed to the king studs and the bottom plate. As you may have noticed, I'm working in a pretty tight space down here. Luckily, my wall is already in 2 pieces. So what I'm going to do is I'm going to actually put the 2 halves of the wall up and then install the header. Now that this section of wall is in place, I made sure it lined up with the other section of wall, and then I used the Tapcon screws to secure the bottom plate and the 16D nails to secure the top plate. Then I measure the opening for my header and cut and install that with more nails, attaching it to the king studs and the jack studs. Now I measure from the header to the top plate for my cripples and cut them to length. The cripples continue the 16 inches on center with the rest of the wall. I marked out their locations on the top plate earlier. There are lots of ways to build a soffit, but this method worked the best for me. It's lightweight, it's easy, and most importantly, cheap. The first thing I'm going to do is head out to my garage and rip some 2x4s into 2x2s. To me, using 2x4s seems like a waste when building soffits, when all you really need is something to attach drywall to. I find it's cheaper to get 2x2s this way, and they are typically straighter. Next, I'll be taking measurements along the ductwork to determine the minimum height I need to build my soffit. Then I just cut the half studs to length with a miter or circular saw. I'm going to use my circular saw for these so I don't have to lug my miter saw down to the basement or run up and down the stairs. You can use a speed square to guide your cut. Save your straightest pieces for your top and bottom plate. You can sometimes still use the not so good pieces by cutting them into smaller lengths. This helps minimize the bend. Then I'm going to basically build a ladder with 2x2, 16 inches on center, just like building a regular wall. Put 1/2 stud on the end, and then the next stud will be 15 1/4 inches from the end, and then the rest should be 16 inches on center. To connect it all together, I used some 3-inch wood construction screws. Nothing special, but I would definitely recommend using something other than Phillips head. I find with the Phillips head, I end up having to push harder to get them to go in without stripping the head. I generally prefer something with this Torx head. Just 1 screw in each half stud is fine. Just make sure the studs are straight. When you get to an end, it's a good idea to pre-drill the hole. This will reduce your chances of the wood splitting. Now that I have this vertical part of the soffit built, all I need to do is screw it to the joists. To do this, I measure out from the side wall on both ends and put a mark on the joist where the vertical section will go. Then I put a reference mark where the middle will be, just in case your assembly isn't perfectly straight. Next, I lift the section and use clamps to hold it in place while I start screwing it on. When you get to the ends of the soffit, be sure they're hitting the walls square. You may need to add some drywall nailers to both hang drywall and attach the soffit to. Next, I'll use a long 2x2 and hold it up against the wall to mark out the half stud locations. Then I measure the length of my half studs, cut them to length, and then screw them to the long 2x2. Then I just screw the soffit section to the bottom of the vertical section. Then make sure each half stud is level and screw it to the wall stud. I intentionally offset the joints of the long 2x2 to improve the strength and straightness. Be aware that with this method, the first stud is offset from the regular 16-inch on center, so you will need to cut the first piece of drywall so it lands correctly on the studs. And for this last little section, I just decided to use some scrap wood and kind of build it in place versus on the floor. Then I just screw them all in place. Make sure you keep checking every now and then to ensure you have them level and in line with each other. If your half studs aren't in line with each other, you will end up with wavy drywall. Now that I have walls, I can put some electrical in them by installing electrical boxes and wiring. I'm going to start off by installing all my electrical boxes for my switches and outlets. I like using these deep nail-on electrical boxes. They're easy to install and you can fit a lot of wires in there without it getting too cramped. You should be able to see some numbers on your electrical boxes. Mine are on the inside and they tell you how many wires you're allowed to run into this box. And I'm not so sure you guys can see this, but the inside of my box says 11, number 14. That means that when using 14 gauge wire, you can have up to 11 conductors going into this box. But keep in mind, all ground wires count as one wire, and each screw that holds the outlet in counts as one. So we automatically can subtract 3 possible connectors. So in this case, I can run up to 9 hot and neutral wires into this box. And what all that basically means is I can run up to 4 14-2 wires into this box. For the location of the outlet boxes, I use the 6-12 rule. You need to have an outlet within 6 feet of all entry points to the room and one at least every 12 feet. The reason for the 6-12 rule is because most floor lamps have a 6-foot cord. This is a minimum for code. I plan to have more outlets than that. I feel like I never have enough outlets. Once you've marked out where you plan to put each outlet box, you can nail the boxes to the studs. For the outlet height, it's best to keep it uniform with the rest of your home. So find an outlet and measure the distance from the floor to the bottom of the box. And if you don't have any other outlets around that you can reference, you can mount your box 12 inches from the top of the floor covering to the bottom of the box. Most boxes will have these marks on the side. When you put the box on the stud, bump these against the face of the stud. That will give you the right position for 1/2-inch drywall. And now for the switch boxes. There needs to be one near all entry points to the room. There's no standard for the height of the box, but most electricians mount the box 48 inches from the floor to the top of the box. I'm going to match what I have in the rest of the basement. I'm going to have one light switch over here for my main lights, and another light switch over here for the lights above my desk and workbench. Now on to the ceiling boxes. Building code requires you to have one switch light in every room, but that could even be a switched outlet. So I'm going to have 4 lights in the main part of the room and then another 3 lights over here over my work area. Let's bring some light to this dark place. As you can see, I have a ton of HVAC running up here, so conventional recessed lights weren't possible, but I still wanted something with that recessed light look. So I'm going to go with some LED disc lights, which just need a regular electrical box. In order to get the lights exactly where I want them, I bought several types of ceiling boxes. So this is a standard ceiling box and attaches directly to your joists or studs. This box has adjustability in case I want to put my light in between 2 joists. This pan box is only 1/2 inch deep and can be mounted directly to a joist or stud. However, you can't have any junctions in this style box because it's too shallow. So basically, wire can come in for a light, but it can't continue to another. When using a pan box or any other metal box, be sure to add a ground screw. All metal boxes need to be grounded. I first took some measurements to make sure all my lights were as evenly spaced as possible and the same distance from the walls. Then, depending on the type of box, I just screw or nail all of my boxes in place. Be sure your boxes are sticking down just a little less than whatever thickness your drywall will be. The adjustable boxes in the 2x2 soffit need an extra 2x2 on top to be able to position them at the correct height. The metal boxes will also need a snap and grommet to protect the wire and hold it into the box. Make sure all your boxes are mounted straight or your lights could end up crooked. It's easier to fix it now before the drywall is installed. Once all my boxes were installed, I ran my home run. The home run is a wire that comes from your panel and feeds everything that you want to power with either a 15 or 20 amp circuit. I'm using a 15 amp circuit for this room, so I just need to use 14 gauge wire or 14-2. If you decide you need a 20 amp circuit, you will need 12 gauge wire or 12-2. A 20 amp circuit is usually only needed for rooms with equipment with a heavier draw, like a laundry room, bathroom, kitchen, or possibly a garage. I'm using a 3/4 inch drill bit to drill all my holes, and I put a link to this one down below. For my home run, I was lucky enough to have some existing holes I could use. But when you're drilling your holes, be sure to check on the other side before you drill your hole to ensure there's nothing important on the other side. If running parallel to a joist, you need a staple every 4 feet. If you need to drill 2 holes near each other through an engineered joist like this, you need to ensure there's at least twice the larger hole in diameter spacing from edge to edge. Run your home run wire all the way to the closest electrical box that you installed earlier. Be sure to leave plenty of extra wire on both ends. I like to label the home run and any wires going to switches. Now run wire into each electrical box. Again, be sure to leave plenty of extra wire sticking out. For the switches, you'll need to run wire from an outlet into the box and then in series to each light it will control. When drilling holes in the studs, be sure to drill in the center. A 3/4 inch hole in the center of the stud ensures screws and nails won't hit the wire without a nail plate. If you have less than 1 1/4 inch from the edge of the stud to the edge of the hole, you will need to add a nail plate to protect the wiring. Drill your holes at a comfortable height. For me, that's at about waist height. You also want to make sure you drill all your holes about the same height to make the wire easy to pull through. There's nothing in the building code that dictates the height of the holes. Be sure you're adding staples within 8 inches of all electrical boxes and a staple every 4 foot. When the wire goes through a hole, that is considered a staple. You can put up to 2 wires in a staple. 3 wires or more will require a staple and a zip tie. When you're all done with all your wiring, fill all the holes going through the top plate or into other wall cavities with fire-resistant expanding foam. Next, I finished out all the boxes to protect them from the drywallers, but also to prepare them for the work I need to do after the drywall is installed. This is 14-2 wire. It's called that because all the wires are 14 gauge and there are 2 wires and 1 ground. This one right here that's bare is the ground. This one that's white is called the neutral, and this one that's black is called the hot wire. I mean, it's not really hot, but I mean, I can touch it, but I mean, it will be later, I guess, once I hook it up to the circuit breaker, but you know what I'm saying. Anyway, I'll start with the outlets. First, I strip the sheathing so there's at least 1/8 of an inch still going into the box. Next, I'll connect all the ground wires and add a pigtail. Then I'll cut all the wires so there's at least 6 inches sticking out of the box. Now carefully fold the wire and put it back into the box. Most ceiling lights already come with pigtails on them, so I'm just going to cut the wires with a little more than 6 inches sticking out of the box, strip off the sheathing, then splice all the wires together and fold them back into the box. Now for the switches. Most basic switches do not need a neutral wire, so you can just connect those and push them back into the box. If your switch does need a neutral wire, it's easy to add a pigtail later. Most switches that need a neutral will also include a wire to use as a pigtail. You will also want to pigtail the grounds and the hot wires. Then I take the switched wire that goes to the lights and wrap it around the other wires so I can identify it later. Then cut them all off a little over 6 inches from the box and fold them neatly into the box. When installing the new circuit breaker, be sure to know what type of breaker you need. If a room requires GFCI outlets, it doesn't need an AFCI breaker. If the room won't have any GFCI outlets, then more than likely it needs an AFCI breaker. Rooms where a water source is present will require a GFCI outlet and will not need an AFCI breaker. Once you've determined whether or not you need an AFCI breaker, be sure to know what type of breaker your box requires. My box uses square D breakers. When you're working in an electrical panel, always wear rubber-soled shoes, just in case you accidentally touch something hot. This might reduce your risk of drowning yourself. Speaking of which, I'm gonna put this back on now. If you're not comfortable working with a live breaker box, then the first thing you should do is shut off the main breaker. This is going to turn off all of the power in your home, so be ready. Now you can remove the cover. Pro tip, you can use a number 2 square drive to do everything in the panel. To install breakers in a regular circuit, you connect the ground and neutral on the ground and neutral bar. They are bonded together. For an AFCI circuit like this, the ground goes to the ground neutral bar. Both the hot and neutral will go to the breaker. The breaker will have its own neutral and then goes to the ground neutral bar. I like to install the neutral and hot wires onto the breaker before installing it. It just seems easier to me. Make sure the breaker is off and then install it by connecting on this side, then rocking it into place and snapping it in. Give it a little wiggle to make sure it is properly secured. Then just make sure your wiring looks nice and neat like the rest of the wires in the box. Leave this new breaker off for now until you have your outlets and lights installed. Then put the cover back on and turn on the main breaker. Be sure to label your breaker in the box. Do not use any abbreviations to do this. The electrical is roughed in, so now I can move on to drywall. I'm not going to show you the process of hanging and mudding the drywall because frankly, I'm terrible at it and you don't want to watch that. But I am going to show you how to apply drywall texture if you want to do that. As you may have guessed, spraying drywall texture is a very messy process. So I need to cover anything that I don't want primer or drywall texture to get on. For me, that's going to be the floor, the door, and the ceiling, which I plan to paint black later. And if you're planning to texture a room that already exists with furniture in it, get the furniture out of the room or move it to the center of the room and cover it in plastic. Turn off the power to the room and remove all of your light fixtures as well as your outlet and switch covers. Be sure to protect all the outlet openings with masking tape. To protect the floor, I'm going to be using rosin paper. All you need to do is roll it out and then tape the seams with masking tape. I should have done this when I was mudding this room and I didn't. It was a huge pain to clean up the floor afterwards, so I won't make that mistake again. Next, I'm going to protect this door with some plastic and masking tape, but make sure you do it in a way where you can still open the door so you can get out. Don't ask me how I learned that. Next, I'll be using some more plastic and masking tape to cover the ceiling near the walls. In this case, I don't actually have that much ceiling to cover, so I'm just going to cover all of it. To attach the plastic to the ceiling, I'll be using a combination of staples, masking tape, and just plain jamming it into holes. Don't let all my Hollywood special effects fool you. This is not as fun as it looks. When I'm doing this, I also like to cut around the light fixtures so I don't melt the plastic. I was a little bit wasteful when using this plastic, but honestly, I really don't care because it's pretty cheap. And now that I have my room fully protected, it's time to protect myself. Well, that's better. You guys like my suit? Well, I put a link to a suit just like this and all the other products I'm using in this video down below. By the way, here's a tip I haven't heard in other videos. If you're getting ready to spray texture on bare drywall like I have here, prime the walls first. If you plan to spray your primer, lightly wipe off the drywall dust with a soft broom or a towel. I would suggest wearing a respirator when doing this. If you're going to roll on the primer, you can leave the drywall dust. It can help fill small pinholes and imperfections. The reason I like to prime the bare walls is because the texture I'm about to spray on the walls will dry faster on the joints than it will on the bare drywall. You will end up seeing a slight difference in the final texture where all the joints are. It's subtle, but you can still see it even after painting. I'm spraying this primer with my Graco X5 spray gun. It makes very quick work of a room this size. I put a link to this spray gun down below. Once you're done spraying your primer, you may be able to see some areas that need to be touched up with some drywall mud. After you touch up those spots, reprime those areas. I actually did a pretty good job on this drywall. I am pleasantly surprised. Once the primer is completely dry, we can start spraying texture, but the first thing I need to do is get my texture gun assembled and ready to go. Make sure the adjustment valve is working properly.
If your texture gun didn't come with this valve, I recommend adding one. It's great for making changes in pressure on the fly. Install the hopper with the included hose clamp with the handle facing towards you. Then install the compressor fitting. Be sure to use Teflon tape on the threads. This texture gun comes with 3 nozzles. I'm going to start with the medium-sized nozzle for my test, and I'll make adjustments as needed. It helps to squeeze the lever when installing the nozzle. For a room this size, I'm just going to use a pancake compressor. If I were spraying a larger area, I would want to use a larger compressor so it wouldn't need to run so much. I'm going to set the regulator to 30 psi to start out. Now mix up a bucket of texture. Add the water first, following the instructions on the texture package. Then slowly add the texture compound to the water. I'm using an actual texture compound, but I've seen some people use regular watered down joint compound for this. Mix until there are no lumps, then wait 15 minutes for the powder to soak up all the water, then test the consistency again. Add water or compound as needed to get the mix right. You're looking for a runny consistency, sort of like pancake batter. Delicious. No, but seriously though, this might be a little bit thick. Add a little more water. Now pour some of that pancake batter into the hopper and test your finish on a scrap piece of drywall. If it's too runny or too dry, add more texture powder or water and test again. Hold the nozzle about 18 inches from the test surface and spray slowly across the surface. You can touch up areas that need more coverage later. This test will let you know if you need to change nozzles, pressure, compound, consistency, or technique. After about 10 to 15 minutes, the texture you sprayed will start to haze over. That is when the compound is just dry enough to knock down without smearing. Don't wait too long or you won't be able to knock it down. After every stroke, wipe off your knockdown tool with a damp rag. Repeat this test as many times as you need to get comfortable and achieve the desired finish. This was still a little bit wet when I knocked it down, but I knew that because I'm in a little bit of a rush. But overall, I think that the gun is spraying how I want it to, and I think once it hazes over properly, it'll look perfect. So let's move on to the closet. So overall, I'm pretty happy with my test, so that means I can move on to the real thing. I'm going to start here in the closet because it gives me one more chance to dial everything in and practice before I start the main room. I spray the texture in a steady back and forth motion. Work in small sections and try not to overlap the spray too much or you'll get buildup. Be sure to keep the texture gun perpendicular to the surface. Pay attention to the time. I only spray for about 10 to 15 minutes until I notice the first texture I sprayed starts to haze. Then I go to work with the knockdown knife. Just like watching paint dry. I'm using this large plastic knife. I like it because it covers a large area and has a lot of flex, so it makes it easy to apply even pressure. I put a link to one like this down below. You may also need a smaller drywall knife to get into tighter spaces. Well, that went super well, and I think I'm ready to do the rest of the room. The one thing I did learn is I think I might want to apply a little bit more texture to the walls in the main room. Other than that, perfect. Once the closet looks exactly the way I want, I continue with these same steps on the rest of the room. The most important thing is to pay attention to how long you've been spraying, so you don't miss the perfect window to knock down the compound you sprayed on the walls. When knocking down the texture, start at an edge and use light, even pressure while dragging straight across the surface. Stop about 2 feet from the other end. Then go from the other end to carefully finish that last 2 feet. Remember to wipe off the texture knife after each pass. Each pass should overlap the previous pass by around 2 to 3 inches. Remember, this is called knockdown texture. It's called that because you're only knocking down the peaks of the texture you sprayed. I used about 1 bag of texture compound for a room this size. But keep in mind, I don't have a drywalled ceiling.
If you have a fully drywalled ceiling, you'll want more than one bag. I'm all done with the texture in this room and I'm going to let it dry overnight. It's the next day and the texture is dry and looks as fine as fried cheese curds on game day. So let's finish up with some more primer. Which means time for that goofy suit again. I'm using my Graco spray gun again to apply the primer. It does a great job applying an even finish very quickly. It's also a lot easier to get good coverage on textured drywall with a spray gun. If you don't have one, use a roller with a long nap. After I'm done priming, I'm going to spray my ceiling black. So I'm going to leave my rosin paper on the floor and just remove the plastic from the ceiling. At this point, the primer just needs to dry and your walls are ready for paint. Everything is textured and painted, so now I can move on to the finished electrical work. It's time to replace these temporary lights with some nice LED wafer lights and install some outlets. I'll be using these Leviton tamper-resistant outlets, these Z-Wave dimmer switches, and these Sunco LED wafer lights. If you're interested in any of these, I put links down below. Before you get started, shut off the power and make sure you have some lights so you can see what you're doing. If I didn't have my camera lights, I'd probably use my headlight. It's super goofy looking, but your hands are free to work instead of holding a light. Don't be a hero. If you're uncomfortable with anything I do in this video, hire a professional. Once the power is off, I use a voltage tester pen and an outlet tester to ensure everything is powered down so I don't electrocute myself. Again. I put a link to these tools and all the other tools I'm using down below. My drywaller was super messy. So the next thing I need to do is clean all the drywall mud out of my outlet holes. I need a new drywall guy. You only need to clean enough out of the hole to get to the screw holes and fit the outlet into the box. To clean the drywall mud out of the hole, I just carefully use a utility knife and a straight edge. Just take your time and be careful not to damage the drywall that won't be covered by a faceplate. I installed a temporary outlet, so I have one to use when I was drywalling the room. So first I'll take that one out. When I remove an outlet I don't plan to reuse, I just cut the wires off close to the outlet and then restrip the wires. You'll want to strip them back about 3/4 of an inch. Once all the wires are stripped, you attach the white or neutral wire to the silver terminals on the new outlet, and the black or hot wire to the brass terminals. The ground wire goes to the green screw. Some people really don't like using these holes in the back of the outlet to secure the wires. While I agree that that is not as secure as using a screw, I've never had any issues when doing this. In fact, if you have a newer home, your builder probably used these to save time when building your home. Because I'm not in a hurry and I like to err on the safe side, I'm going to attach my wire to the screws themselves by curling the end of the wire like this. Loosen the screw and put the wire under the head of the screw. Install the curl of the wire oriented so the curl gets tighter as you turn the screw to the right. Now tighten the screw down. Repeat with all 3 wires. There are 2 mounting screws for each color wire on these outlets, and there's 1 for the ground. If you have more than 2 white and black wires coming into the box like this, you can either push the additional wires into the holes in the back of the outlet or make another pigtail. The ground should already be pigtailed together. If you need to make a pigtail, just strip the wires you want to connect and then wire nut a scrap piece of wire to them. Then you can just push the wires back into the box and attach the pigtail to the outlet. Most outlets have these little tabs on them that can be bent back. If the drywall is too far away from the box to support the ends of the outlet, you can bend these tabs back until they hit the outlet box so it's properly supported. To install the outlet to the box, just push all the wires back into the box and then start screwing the outlet into these holes with the captured screws. As you're screwing in the outlet, bend it left or right to make sure it will sit flat against the drywall. Tighten the screws almost all the way down so you can slightly move the outlet. Place a small level on the outlet to make sure it's level, then tighten the screws. Now just install the faceplate. I like having all the screws oriented with the slot vertical. Repeat these steps for all your outlets. If for some reason your smaller faceplate doesn't cover the hole where the outlet is, you can actually buy larger faceplates. Personally, I prefer the smaller faceplates, even if it means I need to patch the drywall later. Now let's install these LED wafer lights. I went with this style because I didn't have room for recessed lights with all the stuff going on in my ceiling. These lights require a normal ceiling box and have a similar look to recessed lights. These lights are dimmable and only use 15 watts each. I selected 3000 Kelvin temperature lights. The lower the number, the warmer the color of the light. 5000 Kelvin would be very cool white, almost blue. 4000 Kelvin would be very white. The 3000 Kelvin lights I'm using will give me a slightly yellow, warm colored light. Installing these lights is super easy. Using wire nuts, just connect all the white and black wires. Then connect the last wire to ground. In this case, the ground is yellow and green. Tuck all the wires into the box and then use the included screws to attach the light to the box and then twist the cover in place. The last thing to install are the light switches. I used relatively cheap light switches up until now. My final light switches will be the Z-Wave dimmer switches that work with the rest of my smart home. Most basic switches like this one just need a ground and 2 black wires attached. One black wire supplies power and the other goes to the lights. The one that supplies power is called the line, and the one that goes to the lights is called the load. They've designed these new dimmer switches so you can hook either the line or load wire to either black screw. The dimmer should be marked to show you which is line and which is load. As I said, this one shows that it doesn't matter which goes where. So I'll hook up the 2 black wires first. This new switch requires a neutral wire, so I'll make a neutral pigtail. To make the pigtail, just pull the neutral wires out of the box. Take off the wire nut, add the pigtail wire, and put the wire nut back on. Then push all but the pigtail back in the box. Then hook the white neutral wire to the silver screw the same way. The switches are designed to have the wires pushed into the back and fully secured by the screws. Now install the bare ground wire to the green screw on top. The brass screw is for the traveler wire. That's for a 3-way light. I don't have any of those in this room, so I won't be covering that in this video. Push all the wires back in the box and then screw the switch screws almost all the way in so the switch can still move a little. Then use your level to get the switch straight and tighten down the screws. Finally, install the faceplate and you're done. As I mentioned before, this is a Z-Wave dimmer switch and can be used with a lot of smart home systems. If you have any questions about this, please leave a comment down below. Okay, we are all done. Let's turn the power back on and test our lights and outlets. Victory! Make sure the switches turn the lights on and off and then test all the outlets with an outlet tester. If there are any issues, turn the power back off and double check all your connections. Now that I have light, I can see how terrible the concrete floors look. So next, I'll cover them with some luxury vinyl plank flooring. Luxury vinyl plank, or LVP, is very easy to install, looks great, and is very tough. This flooring I'm using is also waterproof. That just means that all the materials used to make this are waterproof. That doesn't mean that your basement can flood with no worries. You'd still potentially have mold underneath the flooring. So you can't use this stuff in a shower, but you can use it in a bathroom. This flooring is made from a scratch-resistant wear layer, a rigid core, and a built-in sound-reducing foam underlayment, which also adds to a softer feel. The foam on the back is nice, but I also like to add underlayment. You can use it on any floor of your home, but it's only required over concrete subfloors. The manufacturer claims that this underlayment will keep your floor 15% warmer in the winter and 15% cooler in the summer. This underlayment costs a lot more than just regular poly underlayment, but it is softer to walk on and it's quiet. It's also a vapor and sound barrier. If you have any old flooring, you're going to want to start by removing that. I don't have any of that, but I do have some existing flooring that I need to splice into. There are a few ways to do this. I've chosen the way that is the most work, but probably the best end solution. I'm going to remove the transition and the quarter round so I can pull up some of the old flooring. This flooring comes apart the same way as it goes together. Work from one side and carefully pull it apart. Try your best not to damage any of the locking features. It didn't quite go this way for me. I ended up breaking a few pieces of old plank, but that's no big deal. I ended up with one section I'll have to carefully splice in, but overall it worked out pretty well. Once this is all done, I'll be able to continue the flooring the same way I would have installed new flooring. Next, I need to get the subfloor as clean as possible. I'll start by scraping off any leftover paint or drywall mud. If you had carpet in this room, you'll also need to remove any tack strips at this point. Then I'll thoroughly vacuum the floor to pick up any loose debris or dust. Finally, I'll mop the floor. While doing this, I sometimes find more spots I need to scrape. While the floor is drying, I'm going to check the floor for flatness with a long level. Ideally, the floor should be flat within 3/16 of an inch over 10 feet and 1/8 of an inch over 6 feet. If it's not, you may need to grind down any high spots, fill any low spots, or use self-leveling compound on the entire floor. In my experience, I found this particular flooring to be a little more forgiving than that. The rest of my basement definitely had areas that were outside that range, but my flooring conformed to it pretty well over time. This underlayment I'm using is also pretty forgiving. It can help smooth out any minor imperfections in the surface. There are also subflooring systems out there you can buy that will allow airflow under the flooring. They can also help keep the floor warmer in your basement. However, these subfloor systems add height to the floor and are very expensive. I don't want to spend the extra cost, and I definitely don't want to add any height to my floor. I also have a very dry basement, so I'll be laying my flooring directly on the concrete with the underlayment. I'm happy with the flatness of the concrete. If you haven't already, caulk any cracks in the concrete with urethane caulk. This was one of the first things I did when I started finishing this room. Make sure you're happy with the amount of prep you did on your subfloor. Once you put the flooring down, you won't want to pull it back up to fix something you could have addressed now. This subfloor is all prepped and clean, so now I can start laying down my underlayment. This stuff is extremely easy to install. It just rolls out and can be cut with a utility knife. It even has its own adhesive on the edges to attach the next piece. If you need to, you can use duct tape to secure any other loose edges. The most important thing is that the underlayment is laying flat with no kinks or ripples. Don't worry about taping the edges near the walls. It's good to leave that open for some ventilation. The flooring and trim will hold that area down. And now we can move on to the flooring. And just like any flooring, I like to let it acclimate for a couple of days before installing. All you'll need to install this flooring is a rubber mallet, tape measure, square, pencil, and sharp utility knife. I also like having a jigsaw or oscillating tool for odd cuts. You're also going to need some 1/4-inch spacers. I like to just use some scrap flooring for that. I'll start laying my flooring right here where I need to splice into my existing flooring. This flooring can be installed up to 6,400 square feet before needing any transition molding. When laying your first row, set the locking end groove on top of the groove on the previous plank. Make sure they are aligned perfectly. I use an extra piece to hold them while doing this. Then lightly tap on it with a rubber mallet and snap it together. Flooring like this will always have a little variation from box to box, so it's a good idea to work from several boxes at a time. Well, that wasn't as fun as I thought it was going to be, but I finally got the transition done from that room to this room. So now I just need to continue laying flooring as normal. The nice thing about this flooring is I can lay it this way or this way, which is pretty much perfect for this situation. If I wasn't tying this into my existing flooring, I would have started on the longest wall. Make sure the last plank will be more than 2 inches wide. When you get to the end, flip the last piece around with the end a 1/4 inch from the wall and mark where it hits the last plank. Score the cosmetic side several times with a utility knife and a square, and then just snap it off. You'll need to cut the foam backing as well. Maintain that 1/4 inch expansion gap around the entire room. Use spacers as needed to help maintain the gap. For the next row, use a leftover cut from a previous row. However, the piece must be at least 12 inches. If it's not, grab a new piece. Stagger the joints by at least 8 inches. Push the long side of the plank into the previous row and lay it down. Make sure the end of this piece aligns perfectly with the end of the previous piece. Lay it down, then tap the edge with a rubber mallet to make sure it is locked into place. Continue laying the flooring this way. Try to make it look a bit random while keeping the end seams at least 8 inches apart. When you get to a parallel wall like this one right here, ideally you'll have more than a 2-inch plank on the end. But as you guys know, I'm tying into an existing flooring, so it kind of is what it is, but it looks like I lucked out. Just like the other walls, maintain a 1/4 inch gap. I like to flip the plank over and mark the back side and then transfer those marks to the cosmetic side. Use a long straight edge and the utility knife to cut this edge like you did when you were cutting off the ends. Continue like this with the rest of the floor. Maintain a 1/4 inch gap around any obstacles. I'm not ready yet, but when you're all done with your flooring, install your baseboards and you are done. The flooring looks great. but I still have a huge hole where the closet door needs to be. So next I'm going to install that. Before I framed my room, I called my door supplier to discuss what door sizes they had available. Then I selected the size that made the most sense for the space, and they gave me the correct rough opening, which is what you see here. If you're starting with an existing opening, then measure the height and width of the opening and give that to your door supplier. You can always cut the door down a little later if you need to. I have my doors and they came pre-primed, but before I install them, I'm going to paint them. It's actually very important to paint them before you install them because then you can paint the top and the bottom of the door. Painting the tops and bottoms of the door helps seal them and protect them from moisture. You'd be surprised how often this step gets skipped. I'll just be painting my doors with a foam roller and high quality interior trim paint. You can also spray them if you like. I painted the rest of my doors this way and they turned out great. I typically give them one coat of paint now and another after I install them. Now I'm going to be installing door jambs. I've seen some cases where people have just used a drywalled opening for doors like this. I wouldn't really recommend that. My doors are solid core and they're heavy. And when they hit that jamb, they can hit it with a lot of force and they definitely dent drywall. I ordered a pre-hung bypass door, which came with the guide rail already installed to make things a little easier. The door jamb may have came with some bracing to prevent damage in shipping. Knock off the bottom braces, but leave the rest on to keep the jamb square until it's installed. I'll attempt to slide the jamb assembly into the framing to see if the jamb needs to be trimmed or if it needs to be shimmed at the top. As you could see, I probably should have measured first because it was very apparent that the jamb needed to be trimmed. It can be awkward to do this with the jamb assembly not installed, so I took careful measurements and then trimmed the bottom with a square and a jigsaw. Now it fits much better. If you have a jamb assembly like this with the track already installed, be sure to assemble it into the door framing with the track opening to the closet side. I made sure the side jambs had a small gap at the floor. That way the floor can still float a little underneath the jamb. The top guide track needs to be flat and level as possible so the door will open and close properly. Use wood shims as necessary. Then use the screws provided to secure the guide track. Next, remove the last support pieces. I also put a few nails in the top jamb. Then shim out the side jambs so they are square to the top jamb, and then secure both of them with 16 gauge brad nails or finishing screws. If the top jamb is level and the side jambs are square, they should be very close to plumb as well. Being square is probably the most important. As I was installing the guide rail, I noticed that there was only one hole for a screw. This seems crazy to me. These doors are very heavy, so I opted to drill one more hole on each end and add 2 more screws. I also went with a little heavier duty screw when I did this. And then this gap right here will be covered by the casing later. Install the roller about 1 1/4 inches from the edge of the door, and for now, just put screws in these 2 locations. Starting with the rearward door, tilt the door and set the wheels into the track, then let the door hang free. Did I mention these doors are heavy? Now do the same with the other door. Now adjust the doors so they hit the jambs equally on the top and bottom. To do this, slightly loosen the screw, then push up on the slot with a screwdriver and retighten the screw. Keep doing this until you're happy with the way the door hits the jamb. Once you're happy with your adjustment, or if no adjustment was needed, run another screw in here to lock in your adjustments. Now I'm going to be installing the lower door guide. Push the doors all the way to one side and observe how they line up with the side jambs. Then find the best spot for your door guide and mark its location. So I have 2 sort of unique situations going on down here. Number 1, I have a floating floor, and number 2, I have a concrete subfloor. To allow the floor to float, I'll drill a larger hole through the vinyl plank. Then I'll drill a smaller hole into the concrete and use concrete anchors to secure the guide. I won't fully tighten the screws so the guide can float just a little with the floor. Next, I want to install some door pulls so I can easily open and close the door. So I'm going to go to my hardware kit that came with my door and pull these out and throw them away. And then I'm going to grab some larger ones like this, and I put a link to these on Amazon, and install these instead. I think they look a lot better. These larger poles will also need a larger hole, so I grabbed this 2 1/8 Forstner bit. If you want one, I put a link down below. But before I drill a big hole in my door, first I'm going to drill a hole in a piece of scrap wood to make sure I'm getting the fit that I want. Once I was happy with that, then I measured an existing door so I could match the location. Then I marked the center of the hole in the new doors. Using your Forstner pit, drill the hole just deep enough to install the pole, then push the pole into the hole. I'll also install the stop so the doors can't slide too far. This is very straightforward. Just move the doors until you like where they stop, and then screw the stop into the door near the top. Now to make this look nice and pretty, I'll install some door casing and a piece of 1/4-inch plywood to cover up the gap at the top. Then all I needed to do was to caulk all the seams, fill the holes, and paint everything with a final coat of paint. The last thing I needed to do was install some door casings and some baseboards, and I was done. And here's my finished basement office / RC car workstation. I still need to add some more decorations and some crown molding to make it feel a little more livable, but I'll get to that. I did install a nice closet organizer to get a little bit more organized, but as you can see, it didn't really work. Well, that is the room that I finished in my basement. If you want to do something like this yourself, you can. Just watch my videos and take it one step at a time. Thanks for watching my video. Don't forget to like, comment, and subscribe, and I'll see you guys in the next one.